My dear students, welcome back to our channel. In this video, I will be explaining the BSc second semester subject Programming in C++ as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Tip for exam preparation. Make sure you practice at least 2 to 3 constructor-related programs, understand how access specifiers work, and write at least one program each for friend function and operator overloading. Unit 2 First important short question is: what is a class? How do classes provide data encapsulation? A class in C++ is a blueprint or template to create objects. It groups data, variables, and functions, methods, together into one unit. In simple words, a class is like a design of a car. From one design, class, we can create many real cars, objects. Syntax: class car, public, string brand, void display, count brand. Data encapsulation. Encapsulation means hiding the internal details and protecting data from outside interference. In a class, we use private members to hide data and public methods to access or modify them safely. Example: class student, private, int marks, public, void set marks, int m, marks is equal to m, int get marks, return marks. This protects marks from being changed directly from outside the class. Conclusion: classes help in organizing code, protecting data, and making programs easy to manage using encapsulation. Next important short question is: 2. What is the need of constructor? How is it different from the member function? A constructor is a special function in C++ that is used to automatically initialize the data of a class when an object is created. Why constructor is needed? To set default values or perform initial setup when an object is created without calling any function manually. Example: class student, int roll no, public, student. Constructor: roll no is equal to 1. Count student created. When we create an object like student s1, the constructor runs automatically. Difference between constructor and member function. Constructor member function. Automatically called manually. Same name as class can have any name. No return type has return type. Used for initialization, used for operations. Conclusion: constructors make object creation easier and error-free by setting values automatically. Member functions are used later to perform tasks on that object. Next important short question is: 3. What is the difference between private, public, and protected members with a program? In C++, access specifiers control the visibility of class members, variables or functions. 1. Public. Can be accessed from anywhere, inside or outside the class. 2. Private. Can be accessed only inside the class. Not accessible outside directly. 3. Protected. Can't be accessed outside the class but is accessible in derived, child classes. Example: hash include iostream. Using namespace std. Class demo. Public. int pubdata accessible anywhere. Private. int privdata accessible only inside class. Protected. int protdata accessible in derived classes. int main. Demo d. d.pubdata is equal to 10, OK. d.pr for data is equal to 20, error. d.pro_t_data is equal to 30 error. Return 0. Conclusion. Use private to hide data, public to allow access, and protected when using inheritance. This helps in data protection and better control. Next important short question is 4. Define constructor and destructor. In C++, constructor and destructor are special functions used for object creation and destruction. Constructor. A constructor is a function with the same name as the class. It is automatically called when an object is created. It is used to initialize values. Destructor. A destructor is used to free memory or clean up when an object is destroyed. It starts with a tilde, and has no return type or parameters. Example. Hash include iostream. Using namespace std. Class demo. Public. Demo count constructor called \n. Tilde demo count destructor called \n. int main. Demo d constructor is called here. Return 0 destructor is called automatically at end. Conclusion. Constructor starts object life, initializes data. Destructor ends object life, cleans up memory. These make C++ programs safe, clean, and automatic. Next important short question is 5. Write a program to declare a class, product, with data members code and price and member methods as display. Create an instance and call the method. In C++, a class is like a blueprint to create objects. It holds data members, like variables, and member functions, like methods. Example program. Hash include iostream. Using namespace std. Class product. Private. int code. Float price. Public. Void set data int c, float p. Code is equal to c. Price is equal to p. Void display. Count product code, code ndl. Count product price, price ndl. int main. Product p1, creating object. p1.setData, 101, 499.99, setting values. p1.display, displaying values. Return 0. Easy to remember. Class is equal to design. Object is equal to product made from design. Set data is equal to input values. Display is equal to show values. This example shows how to create a class, assign values, and display product details. Next unit 2. Long questions. First important long question is: define class and object. Explain the concept of data encapsulation and accessing of member elements with an example. Class. A class is like a template or blueprint used to create objects. It groups data, variables, and functions, methods, into one unit. Syntax. Class name. Data members. Member functions. Object. An object is a real-world entity created from a class. It holds its own copy of data and can use class functions. Syntax. Class name, object name. Data encapsulation. Encapsulation means hiding data inside the class and protecting it from outside access. We make data members private and access them only through public functions. This keeps the data safe and avoids accidental changes. Example program. Hash include iostream. Using namespace std. Class student. Private. int roll number. Float marks. Public. Void setDetails intr float m. Roll number is equal to R. Marks is equal to M. Void display details. Count roll number NDL. Count marks NDL. int main. Student S1 is an object of class student. S1.setDetails 101 88.5 setting values. S1.displayDetails displaying values. Return 0. Key points to remember. Class is equal to blueprint. Object is equal to actual user of that blueprint. Encapsulation is equal to protecting data using private and public. Only class functions can access private data. This concept is very important in object-oriented programming, OOP, and helps in data security and reusability. Next important long question is: 2. Discuss with examples constructors and destructors in C++. What is the order of execution? Constructor in C++. A constructor is a special function that is automatically called when an object is created. Its main job is to initialize data members. Rules of constructor. Same name as the class. No return type, not even void. Can be default, parameterized, or copy constructor. Destructor in C++. A destructor is also a special function that is automatically called when an object is destroyed. Its job is to free resources like memory, files, etc. Rules of destructor. Same name as class, but with a tilde symbol. No arguments and no return type. Only one destructor per class. Order of execution. When the program runs, constructor is called first when object is created. At the end of the program or when object goes out of scope, destructor is called automatically. Example program. Hash include iostream. Using namespace std. Class demo. Public. Constructor. Demo. Count constructor called. NDL. Destructor. Tilde demo. Count destructor called. NDL. Void display. Count display function of demo class NDL. int main. Demo obj1 constructor is called here. obj1.display. Destructor will be called automatically when obj1 goes out of scope. Return 0. Output. Constructor called. Display function of demo class. Destructor called. Key points to remember. Constructor used for initialization. Destructor used for cleanup. Both are auto-called, no need to call manually. Order, constructor functions destructor. This makes the program safe, automatic, and organized in C++. Next important long question is: 3. Explain array of objects with a program. What is an array of objects in C++? In C++, an array of objects means storing multiple objects of the same class in a single array. It is similar to an array of integers or floats, but instead of numbers, we store class objects. This is useful when we want to manage data of multiple items, like students, books, products, etc. Example situation. Suppose we want to store details of 3 students, name and marks. Instead of creating 3 different objects, we can create an array of objects. Example program. Hash include iostream. Using namespace std. Class student. Private. String name. int marks. Public. Void get data. Count enter name. cin name. Count enter marks. cin marks. Void display. Count name, marks, marks NDL. int main. Student S, 3, array of 3 student objects. Input for all students. For int I is equal to 0, I3, I++. Count enter details of student I plus 1 NDL. S, I, dot get data. Output of all students. Count \n student details \n. For int I is equal to 0, I3, I++. S, I, dot display. Return 0. Output sample. Enter details of student 1. Enter name, Ravi. Enter marks, 85. Enter details of student 2. Enter name, Priya. Enter marks, 92. Enter details of student 3. Enter name, Arjun. Enter marks, 78. Student details. Name, Ravi, marks, 85. Name, Priya, marks, 92. Name, Arjun, marks, 78. Key points to remember. We can use arrays to store multiple objects of the same class. It makes code compact and manageable when dealing with many data entries. Array of objects works just like any normal array but holds class instances. This is very useful in real-life applications like employee records, product details, etc. Next important long question is: 4. Write a complete program to demonstrate rectangle class. Make use of concepts, private and public access specifiers, constructors, get and set methods, instance creation. Explanation. In C++, a class is used to represent real-world objects. Here, we create a rectangle class that will have private members to hide data like length and breadth. Public methods to access or modify private data get set. Constructor to initialize values when the object is created. Instance creation, creating and using objects of the class. Example program. Hash include IOStream. Using namespace std. Class rectangle. Private. int length. int breadth. Public. Constructor. Rectangle int L, int B. Length is equal to L. Breadth is equal to B. Setter methods. Void setLength, int L. Length is equal to L. Void setBreadth, int B. Breadth is equal to B. Getter methods. int getLength. Return length. int getBreadth. Return breadth. Method to calculate area. int area. Return length * breadth. Method to display dimensions. Void display. Count length, breadth, NDL. int main. Creating object instance of rectangle class. Rectangle R1, 10, 5. Displaying initial values. R1.display. Count area R1.area NDL. Modifying values using setter methods. R1.setLength 15. R1.setBreadth 8. Displaying updated values. R1.display. Count updated area R1.area NDL. Return 0. Output. Length 10, breadth 5. Area 50. Length 15, breadth 8. Updated area 120. Key points to remember. Private members hide internal data. Public methods allow controlled access. Constructor runs automatically when an object is created. Get and set methods help in accessing and modifying private data. This is real-world OOP, simple and powerful. Next important long question is: 5. Explain operator overloading and demonstrate overloading of any arithmetic math operator. What is operator overloading? In C++, operator overloading means giving a new meaning or function to an existing operator like plus, asterisk, etc. when used with objects of a class. It helps us to perform operations on user-defined data types like classes, just like we do for basic data types. Why use operator overloading? Suppose you have a class called complex that holds two numbers, real and imaginary parts. You can overload the plus operator so that two complex objects can be added using C1 plus C2 syntax, just like integers. Syntax of operator overloading. Return underscore type operator OP parameters. Code. Example program, overloading plus for complex numbers. Hash include iostream. Using namespace std. Class complex. Private. int real, imag. Public. Constructor. Complex, intr is equal to 0, int I is equal to 0. Real is equal to r. Imag is equal to I. Overloading plus operator. Complex operator plus, complex obj. Complex temp. Temp.rel is equal to real plus obj.rel. Temp.imag is equal to imag plus obj.imag. Return temp. Display function. Void display. Count real plus imag indl. int main. Complex C1, 3, 4, C2, 1, 2. Complex C3 is equal to C1 plus C2 using overloaded plus operator. Count result of C1 plus C2 is equal to C3 dot display output 4 plus 6i. Return 0. Output. Result of C1 plus C2 is equal to 4 plus 6i. Summary. Operator overloading gives friendly and natural syntax for object operations. It improves code readability. In the example, plus is overloaded to add to complex numbers just like basic data types. Easy to understand and powerful for real-world object-oriented programming.